Hey guys, this is the problem number 3 from projecteuler.net. The title of the problem is largest prime factor, and the description reads: the prime factors of 13,195 are 5, 7, 13, and 29. What is the largest prime factor of the number, this big number here? Okay, some commentaries about the problem. First, a prime number, I guess everybody knows, that is a number that is just divisible by 1 and by itself. So 5 is only divisible by 1 and 5. And the prime factors of a number are the prime numbers that divides this number. So 5 divides 13,195. And the problem asks us for the largest prime factor. So the largest prime factor of 13,195 is 29. We need to find the largest prime factor for this big number here. There are several strategies we can go for. I think the most naive and straightforward strategy is find prime numbers, and from these prime numbers test if they divide the target number that we want to find the largest prime factor. If they do, you just store them somehow, and then you get the biggest one. That's the most naive approach. Certainly there are better strategies, but let's start with this one first, okay? All right, let's give it a try here, give it a shot on this problem. So let me just create here my directory from problem 3, and then the Python file for this problem 3. And for this problem, I would like first to generate the prime numbers. In this generation, I want to create a function first that tests if a number is prime, and then another function to find the next prime number of a sequence, so that then we can have a sequence of prime numbers, right? So let's just then create the headers of my functions here. The first one is a function called isPrime, which will receive a number of the type int and return a boolean, right? I like to create commentaries for functions because I think this is a good practice. In Python, you create a commentary in this way. So this check if a number is a prime number, right? And this is like a number, and it returns true or false. Okay, so how to test if a number is a prime number? So there are several ways, several strategies, some more complex than others. I will do the simplest strategy here. We can loop through all numbers that are smaller than n and test if they divide the number n. If so, it's not a prime number. If it doesn't divide, then we have a prime number. Of course, we don't test 1, we don't test n itself, we just test in between. So we can do that by looping through the numbers like this. So for a counter I in the range of 2 is the smallest test that we can do, and n itself, right? We test if the remainder of the division of n by I give us 0. If that's the case, this is not a prime number. This is not a prime number, so we return false. But if we go through that and it is, and we don't find such number, then it is a prime number, right? Let's test some values here, right? So is 2 a prime number? And let's call the function then. Is prime for 2. I want to do the same thing for 3, and let's test another number that is, we know it's not a prime number. For example, 6. Right? What are we expecting here from this result? That these 2 here should give us true, but this here should give us false. So problem 3 again, let's call it and let's identify. And yeah, so we find out that 2 is a prime number, 3 is a prime number, and 6 is not a prime number. So my function is working as intended. There are some edge cases. For example, if I test if 1 is a prime number, it's probably going to break, right? So for example, is 1 a prime number? It's going to say it's yes, but we know it's not. So we can just add an exception here. So if n is smaller than 2, 2 is the smallest prime number we know, we just return false, right? this should solve our edge cases. Now, if we try again, 1 is false, right? So, okay, great. We have the function to identify if a number is prime. Then we can go through the numbers that are smaller than our target number and test if this number is prime and if it divides the target number that we're looking for. If that's the case, then we just get the largest one, right? So let's give it a try then. The target number, or the number, right, that we're looking for is, let's use first our example, 13,195, right? And we gonna test all numbers that are smaller than our number. And if this number is prime, right? So, and number mod I is equal to 0. So if the rest of the division by this number is 0, then we know that this is a prime number. So in this case, the largest prime is going to be I. And then we can print this largest prime. We'd better initialize this. So let's give it a try for our example, right? So 3, 2, 1, run. And we have the result. The largest prime number of this one is 29. Okay, so does that mean we solved the problem? Well, kinda, because this number here is kind of really big. So I'm not sure that this code will run for such a big code. We can give it a try. So for example, let me just comment it here and put this one. But I think this is gonna run pretty much forever, right? So this solution is not good enough for what we're trying to do here. We have to improve. How can we improve this? Here we can see that we are testing every single number that is smaller than our target number, and we don't have to do that. And for every single one of those, we are testing if they are a prime. Again, we don't have to do that. We just have to get the next prime somehow, right? So if we generate a list of primes, then we can do that. Or if we just have a function to get the next prime, this should be a little bit easier for us to solve. And we also, again, we don't have to test every number. We just have to test up to at least a half of the number, right? So no number bigger than the half or the square root of a number will divide that number. First, let's look into the next prime. I think we can create a function that will look for our next prime number. And then we use that function to iterate through that, not through something like this. So my function is going to be called next prime. So given a number, it will give you another number that it will be the next prime of this function should generate the next prime given an integer, right? So number next prime of the next larger prime than number n, right? So how do we do this? We can just start with n, right? N equal to n plus 1, and while is prime of n is false, or while not is prime, we just go n plus 1, and then we return n. That should do the trick. Just to test our function, I'm just going to comment the remaining of the code here. And we're going to generate the next prime of 2 should be, so for example, next prime of the number 2. We are expecting it to be 3. Same thing, next prime of, let's say, 7. We expect it to be 11, right? So let's give it a try. Yes, that's right. Next prime of 2 is 3. Next prime of 7 is 11. So our function is working. So let's modify here our loop to solve that issue, right? So again, let me just start with the smaller example, and then we go through the biggest one, right? So this here doesn't change, right? And we don't have to test if it's prime anymore, but we have to start with the prime. So we start with number 2. We're going to remove this for loop, and we're going to do like this. While prime is smaller than, for example, n over 2, right? So, or number over 2, right? Number over 2. Then we check if the number is divided by the prime. If that's the case, we have the largest prime. If it doesn't, we get the next prime in our sequence. So next prime of a prime. That should work. Let's try it. Yes, it works for the small case. Let's see if it holds for the biggest case. And yeah, so the actual problem is still, it doesn't hold for it. It's going to take a long time to run that, mostly because we're still trying a lots of numbers. So we're trying every single prime that is smaller than 300 billion. Like it's so much tests that we have to do, right? So it's still not a good solution. But remember, we are looking for the prime factors. Another way that we can do this, and it's efficient, is that we always reduce our search space. So if we know that this number is divisible by 2, we can just divide it by 2 and test if it's divisible by 3, right? And if it's divisible by 3, we can just divide it by 3 and check the result if it's divisible by 5, and consecutively for all the primes. There is a different strategy that we can go here. Instead of testing every single prime number, we can test while this number is bigger than 1, right? And every time we're going to update this number. If this number is divisible by the prime, then we're going to just update the number, right? So the number is equal to the number itself divided by the prime. Otherwise, if it's not, we update the prime. That should do the trick for our case. Let's test first in our small case, and then we test for the target number. So again, it holds for the smallest case. Let's test for the bigger case. In this case, I'm always divide this number by the prime number that we have at hand, if it's divisible by that prime number. If that's the case, then this number is always becoming smaller and our search space is smaller. It's basically that like we are reducing our search spaces to only the prime numbers. In the end, we're just going to have like the largest prime that we divide that number for. So let's run it very, very fast because this complexity reduces a lot. First, so let's analyze the complexity of each of these functions here so that we can understand what's going to happen here. So first, the isPrime function, the complexity of it is a linear complexity. So I'm having to test every number that is below that number to test if it's a prime number. So it has a O of n complexity. But this is like, it's still not good because we have to test everything. And we're calling this function every time as well in the next prime number. So basically, if the number is 6,857, I had to call that function this amount of time. So it's still not as good as it can be. But for this problem is good enough. Well, I didn't test if this problem actually, this is the solution to the problem. Let's give it a try. I think it is. So 6,857, let's paste it here. Come on. Yes, and that's right. So congratulations, this is the correct answer. Right. Can we make this even faster? Yes, we can. There are several ways that we can improve the prime number generation. We can also test here what is the speed that we have, how much time it takes to generate this problem. So I want to do the same thing I did for the previous problem. So I want to do some profiling here to test the time. So we can just time. It is the date time, but now minus the start time. Right, I just want to calculate the speed it takes here. And it takes less than a second. It's like some 8 milliseconds. But there is actually just one thing that we can do here to make it faster. Right now, when we're checking if a number is prime, we're checking from 2 all the way to the number -1. We don't have to do that. We can reduce the search space to check if a number is prime. We just need to check up to the square root of this number. Let's calculate here the square root. This should improve our isPrime function of n. We need to check the square root itself, and it needs to be an integer. So math.floor. Math.floor.square root. What am I doing here? I'm calculating the square root of n, and then I'm getting the floor function. It means like the integer part of the square root, and I'm adding 1 just because this number should be included, right? This should improve this number slightly. Let's check the difference. And yes, it is 1 order of magnitude faster than this, but the difference is not so big because this is not a very complicated problem. But yes, this is the best solution that we can get so far. Yes, we can make better functions for generating prime numbers, functions that will be more efficient, but we're going to do this in other problems. Right? For this problem, this solution is more than enough to solve it with a good time. So thank you so much for watching this video. If you liked, share, subscribe to the channel, turn on the notification bell. This helps a lot. Thank you so much, and I see you on the next time. Ciao.